Let's talk a little bit about something that is basic, but if you don't understand it, it can confuse a lot of other things with oscillations like mass spring systems and pendulums. And that is, what is the restoring force and what you need to know about restoring force. So restoring force for simple harmonic motion is the force or component of force that's always pulling the object back toward the equilibrium position. So like when you have a mass spring system, your restoring force is the spring force. And when you have a pendulum, the restoring force is the component of gravity that is like perpendicular to the string. So essentially it's almost like an X component of the gravitational force that's always pointing back toward the equilibrium position. And the thing that you want to know about the restoring force is that the restoring force magnitude is not constant. The farther you are from the equilibrium position, the greater the magnitude of the restoring force. So with spring force, that one's very obviously shown with Hooke's law. So Hooke's law, the spring force is proportional to displacement. So like the further you stretch the spring, the greater the spring force. And also too, if you were to look at a force diagram of a pendulum, when it's like pulled at its furthest position, that component of gravity is going to be larger, but as the pendulum bob moves toward the equilibrium position, that component of gravity gets smaller and smaller and smaller until eventually at the equilibrium position, the magnitude of the restoring force is 0. So I hope that helps you understand a little bit more about just what restoring force is, and keep a lookout because in our next video, we're going to talk more about restoring force and the connection between the restoring force and acceleration and how that relates to velocity at different points along the motion of a mass spring system.